Okay, welcome to the first lesson on complex numbers. We're going to be looking at complex numbers, what they are, imaginary numbers, what they are, and an Argand diagram. We'll see what that's all about. So the number one, we'll start here. Number one is our base unit for counting. You can have one lot of one, two lots of one, three lots of one, 27 lots of one, all the way up to infinity, half a lot of one, a sixth of a 1, pi lots of 1, negative, even if you want, negative pi lots of the number 1, anything, any number that you can imagine goes on this axis, or does it? What about the square root of negative 1? It doesn't go at negative 1 or 1, it doesn't go there. You need to think, what number times itself gives you negative 1? Well, a negative times a negative is a positive. So a negative number squared is a positive number. What number times itself gives you a negative number? What is the square root of negative 1? The answer is I. I is the imaginary unit. So if 1 is the unit, then I is the imaginary unit. So I'll just draw another number line here. This will start at 0. We could have I, 2 lots of I, 3 lots of I, 27 lots of I, pi lots of I, half an I, a sixth of an I, negative I, negative 2i, negative pi I, all the way down and all the way up. I don't know if infinity I makes sense, but you get the point. It goes on and on. So to look at this a bit more clearly, what this actually means, let's think about a quadratic equation. We've seen the discriminant before. If b squared minus 4ac is bigger than 0, we've got 2 roots. If it's equal to 0, we've got 1 root. If it's less than 0, we've got 0 roots. But 0 real roots, you'll have seen this at some point, or 2 real roots. What does that mean? Well, if we've got 0 real roots, we still actually have 2 roots. They're just not real numbers. So they're not numbers that fall on that real number line that we started with. They're imaginary, or probably more often a combination of an imaginary and a real number, which we call a complex number. So for example, here's x squared minus 6x plus 5. We want to factorize that. We can factorize it like this, and that will give you b squared minus 4ac is greater than 0, so we get 2 real roots. But what if I change this equation up, and now I've got x squared plus 4x plus 5? How do you factorize that? What two numbers can you add together to give 4 and multiply together to give 5? Now if we do b squared minus 4ac, we're going to get a number less than 0, which means we've got 0 real roots. So let's explore that a little bit further. What if we took the quadratic formula and we use that to find our roots? Well, negative b plus or minus, and we'll just swap in all the letters for the values we've got. That's going to give you negative 4 plus or minus the square root of 16 minus 20 is negative 4 over 2. That will give you this here. So this negative 4 under the square root. Square roots we'll call surds, and there's a property of surds. We'll cover these a bit more. Surds will be a lesson onto their own. There's a property of surds that says if you've got a number under the square root, you can break it up and then split it apart. So the square root of 8 could be the square root of 4 times 2, which could be the square root of 4 times the square root of 2. Square root of 4 is 2, so it'll be 2 lots of the square root of 2. We'll apply this to the square root of negative 4 now. So that could be the square root of negative 1 times 4, the square root of 4 times negative 1, which is 2 times the square root of negative 1. Square root of negative 1 is I, which we covered earlier, the imaginary unit. So this means our quadratic formula will lead us to this point here. Negative 2 plus or minus 2i over 2, which is negative 2 plus or minus I. So our answers for x are negative 2 plus I or negative 2 minus I. So we have two roots still, they're just complex numbers. Now what does this mean? What does complex mean? It means it's a number, but it has a real part and an imaginary part. So it's got a real number from the real axis and an imaginary part from the imaginary axis, which we covered. We by default write the imaginary part following the real part. So the real part here is negative 2, the imaginary part is I, or 1 lot of I. So I'll just draw my axes together. There's the real axis going across like you used to, and the imaginary axis going up and down. Just for ease of understanding, we draw these at right angles. This is just a convention, but we've got all the values of the real axis and all the values of the imaginary axis. I've labeled one I there. We actually don't use the value of I on the graph. We just plot its magnitude, but just so you can understand that it's the imaginary axis. And we can plot the imaginary part against the real part, and that will give us the complex number as a combination of both those two. And I'll draw it just as a vector, as an arrow in this case, because we'll come to that a bit later on, so it'd be good to be familiar with it now. But we can just think of it as a point in space, in two-dimensional space, not on a number line, but in a plane, complex number plane. It is an x and a y coordinate, which is the real and imaginary part, which is negative 2 and positive 1. That 1 representing 1 lot of I. So our two numbers are that, or x equals negative 2 minus I. So the only thing that's changed is the sign before the imaginary part. And we call these complex conjugates. When you have to solve to find complex roots, you're going to get complex conjugates, which means it's the same number except we got that plus or minus, then we have the imaginary part. So here's my diagram again, showing my two-dimensional space with an imaginary part and a real part. We use this and we call it a Argand diagram, which is what we use to draw or plot our complex numbers. For instance, the number 0 plus 2i, which is just 2i, it's a purely imaginary number and it sits on the imaginary axis. And the number 2 plus 0i, well, that's just the number 2. It is purely a real number and it sits on the real axis. Anything else sits in this space here between the axes, and that's our complex numbers, our complex number plane. So we write this often as x plus iy, which means that I times then however many real parts, imaginary parts you have. So y is the imaginary axis and x is the real axis. So for instance, the number 4 is 4 lots of the number I, or 4 lots of